Right, we're looking at a topic now called expected outcome, meaning in a given situation, what do we expect the result to be? Not each individual time, but over time on average. And the way we're going to look at this is look at a couple just sort of made up what you might run into at the carnival game sort of thing. First one I want to look at, very simple game. You flip a coin. If you flip heads, you win $1. If you flip tails, you win nothing. So what would you expect on average over time? Some of the time you're going to win $1, some of the time you're going to win nothing, but over time it's going to be somewhere between those two situations. And the way we're going to calculate that, it's really very simple. You just look at each outcome, multiply it by its probability, and add them together. So our first possible outcome is that you win $1, and the probability of that happening, as we've beaten to death, is 1/2. The other outcome is 0. The probability of that is the same as the probability of flipping tails, which is 1/2. Add those together, you get 1/2 plus nothing, which is 1/2, or in the sense of money, that's going to be 50 cents. Right? So you're never actually going to win 50 cents at this game. You're always going to win either $1 or nothing. But on average, over time, your winnings are going to average out to be 50 cents. And what use that is this is sort of the break-even point for how much you're going to pay to play this particular game. Or if you're talking stock market, how much you're going to pay to invest in this particular investment opportunity. Because if you pay 50 cents, it's a break-even game. You might enjoy that if you're a gambler. You win some of the time, you lose some of the time, you get that adrenaline rush or whatever. But if this game costs $1 to play each time, then on average, you're going to lose 50 cents every time. And you'd kind of be a sucker unless the game was to benefit a really good cause. On the other hand, if the game costs $0.25 to play, then I'll play this one all day long, because on average over time, I'm going to win 25 cents back. I'm going to pay $0.25, but I'm going to win 50 cents back, which is a profit of 25 cents. Okay, so that's what good expected outcome is for us. Let's look at a couple more slightly more complicated situations. Here's another game. We roll a die, 6-sided die. If we roll a 6, we win $5. If we roll a 4 or 5, we win $2. Anything else, we win nothing. So what's our expected outcome? Well, we might win $5, and the probability of that is 1/6, because that's the probability of rolling a 6. We could win $2, and the probability of that is 2 of our outcomes out of 6, so that's the same as 1 out of 3. And then we might win nothing, and the probability of winning nothing is half, right? Because a 1, a 2, or a 3 will win us nothing. So our probabilities add up to 1. What do we get if we add all these guys up here? Well, I took the liberty of doing that earlier. It ends up being $1.50. Can't do it in my head. I apologize. So our expected outcome for this game is $1.50. If we pay anything more than $1.50, then on average over time we're going to lose money at this game. Every once in a while we're going to win. Sometimes we're going to come close to breaking even. If it's $1, if we're paying $2 to play, this would be break even. Half of the time we're going to lose, but on average over time we're going to lose 50 cents. If we were paying $1 to play, then on average over time we're winning 50 cents. Again, I play that game all day long, although it doesn't sound very interesting. Maybe a better way to spend my time. Game 3 here. Suppose we roll a die and we have $1 for each pip that's showing on the top side of the die. Each one of the dots is called a pip. So there's a 1 in 6 chance that we'll win $6. There's a 1 in 6 chance that we'll win $5, etc., etc. You can work out the math if you want to. That should work out to $3.50. So again, if this was a $3 game to play, I play it a bunch of times. If it was a $4 game to play, I wouldn't bother playing it at all, because I'm going to lose 50 cents each time. Again, unless it was for a good cause. I'll lose 50 cents to a good cause. Hope that makes sense.